In dealing with problems involving projectile motion, we can use the kinematic equations that we discussed in our previous lessons. So for vertical motion, or vertical component of projectile, we can use these equations. So Vf is equal to V naught, or final velocity is equal to the initial velocity plus the acceleration times time. Also, we can use delta x, or the displacement, is equal to 1/2 times the final velocity Vf plus V naught, or the initial velocity, and then multiplied with time. Okay, and then next is delta x is equal to V naught times time plus 1/2 at square, and lastly we have Vf is equal to, or Vf square is equal to V naught square plus 2a delta x. We use these kinematic equations that has acceleration, since the vertical component of projectile motion has constant acceleration, while if we are dealing with horizontal motion, or the component that has zero acceleration and constant velocity, so we can use the equation V is equal to d over t, or d is equal to V times time. Okay, we use these equations to solve problems involving projectile motion. So for our first problem, a rifle is held perfectly horizontal 1.5 meters over level ground. At the instant the trigger is pulled, a second bullet is dropped from the tip of the barrel. The muzzle velocity of the gun is 80 meters per second. So the first question is, which bullet hits the ground first? Second, how fast is the bullet, or each bullet, moving after 0.3 seconds? And how far away does the fired bullet land its range? So let's answer the first problem, or the first question first. So which bullet hits the ground first? Definitely they will fall, they should fall at the same time. Okay, now based on the video lesson, you learned that the only component that is affected by the gravity is the vertical component of the projectile motion. So considering that we ignore the air resistance, the acceleration of the two objects on the y-axis is the same. Therefore, they will fall, or they will hit the ground at the same time. Now, number 2, how fast is each bullet moving after 0.3 seconds? Now note that we have initial velocity of 0 meters per second, and acceleration, which is equal to negative 9.8 meters per second square, while time is equal to 0.3 seconds. So given these values, we can use the equation Vf is equal to V naught plus At. Okay, now since velocity, the initial velocity is 0, so we can just cancel this one. Okay, and we can substitute the Vf. So the Vf here should be the final velocity, or the y component velocity of the bullet after 0.3 seconds. So that's Vy. Okay, so this Vy is equal to the negative 9.8, which is the acceleration, so square, times 0.3 seconds. So therefore Vy here is equal to negative 2.94 meters per second. So the negative sign indicates that it's moving downwards. Now this Vy here is the velocity of the object, or the bullet that is dropped after 0.3 seconds. At the same time, it's the y component of the velocity of the bullet that is fired after 0.3 seconds. Now since we are concerned with the total velocity of the bullet that is fired after 0.3 seconds, not just the y component, we can get, or we can calculate v using the Pythagorean theorem, since we're given with its components vx square plus vy square. Now we know that vx here, the initial velocity, or the initial horizontal velocity, is 80 meters per second. So that's 80 meters per second. So substituting that to the equation, the square root of 80 square plus the vy, so that is negative 2.94 square, that must be equal to 80.054 meters per second. So in the direction, of course, the direction of this is tangent to the path, or the trajectory. So this will be our answer for v, and this is dy, or the final velocity after 0.3 seconds of the bullet drop. So this one is for the bullet that is fired. So the next question is, how far does the bullet, or the fired bullet, land, or we are looking for its range. Now to get that, so we can use the equation d is equal to v naught t plus 1/2 80 square. So to get the time, okay, so first we need to get the time, since we don't have any time. So v naught here is 0, and rd is negative 1.5 meters. So that is equal to 1/2 times negative 9.8 meters per second square times the time here. So we're looking for this. So we have to isolate t here. So therefore we have t is equal to the square root of, so we can multiply 2 by 1.5, so that's 2 times negative 1.5 meters divided by negative 9.8 meters per second square. So which gives us time which is equal to 0.5533 seconds. So this is the time it takes for the bullet to reach the ground. Now, since this time is true to both the horizontal and the vertical components, we can use this time to solve for the range. So to solve for the range, so that's the horizontal distance, and since the velocity is constant in the horizontal component, we can use this equation. This is equal d is equal to vt. So therefore 80 meters per second. So since that's the velocity on the x component multiplied with time, so 0.5533 seconds, that should be equal to 44.26 meters. So this will be our range.